click these two columns and go here on this straight line, you will see that directly it is first necessary to calculate the order of the reaction with respect to the species A, B, and C. So let's start. Hello guys, in this video we are going to see how to determine the kinetic law. To do that, we will see two exercises. First exercise, it will be how to determine the kinetic law by the construction of a straight line, and we will do this using the computer. Second exercise will be how to determine the kinetic law during your examination. So stay tuned and watch the entire video. Let's start. So, how to determine the kinetic law? First of all, in my previous video, I taught you what is the kinetic law. So, if you don't know that, please watch my previous video and everything will be clarified. So, to determine the kinetic law, there are different kinds of methods. The most used method is called the method of initial velocity. This method is applied by measuring the initial rate of the reaction with respect to different concentration of the reactants. So let's take a generic equation as example. Let's take the generic equation A plus B, which turns into C plus D. So let's suppose that for this reaction we have the kinetic law, which is V equal K, the kinetic constant, multiplied by the concentration of A to the A power multiplied by B to the B power. Now, if we keep the concentration of B constant for all of our experiments, we can say that the concentration of B is actually constant. And so we can take the concentration of B and put together with the constant K. Of course, in this case, we are changing K, so let's put a sign to remind us that that K is not actually the kinetic constant, but is a modification of that, because inside that K there is now also the concentration of B. So now our kinetic constant will be simplified to V equal K with this apostrophe times A to the A power. But as we have said, this method is called initial velocity method. So what we have to consider is the initial velocity. So let's change this equation considering the initial velocity and also the initial concentration of A. So this will be our new equation. Now, if we take logarithms, you can see that we get the equation of a straight line, which is this one, with intercept logarithm of K with this apostrophe and slope A, the order of the reaction with respect to A. So, it's clear now that if we are able to build this straight line, we are able to obtain the order with respect to the species A by simply taking the slope of our straight line. Same consideration we can do with the species B. So this time, we have to keep constant the concentration of A and calculate the initial velocity by changing the concentration of B at the initial rate. So we will get a similar equation as we have done before for A, which is actually this one. So again, we will do another straight line, and this time the slope of this straight line will give us the order with respect to the species B. And in this way, we can construct in the end the kinetic law. But let's go to the computer to see an actual example of what we have just said. Let's go. So let's start with this exercise. Let's take this reaction of formation of iodine in the presence of argon. For this reaction, we have two sets of data. The first set of data is with the concentration of argon, which was kept constant, whereas the velocity and the initial concentration of the reagent, the atomic iodine, was measured. And then the second set of data, this time the atomic iodine was kept constant, whereas the concentration of argon was changed, and also the initial velocity was measured. So what we have to do is to take this data and put in a program in order to have our graph and in order to calculate the slope and intercept of our straight line. So as we have said in the introduction, we have to build this straight line with logarithms, and so we will use this program, which is Origin. So I will start a new workbook by pressing here, Now I will just put this data inside this data sheet. The data we will consider is just velocity and the concentration which changes. So the concentration of atomic iodine. We won't consider this because it's constant. So I will now speed up the video while I'm filling this data sheet. So we have our data. Now we have to actually do the logarithm of this in order to build our equation. So I add this new column. Now we will set this column as y and this column as x. So this will be set as x. Now let's set the column value of this column here. Just to set column value. And now we will write log of column A. Okay, so now Origin will directly transform this into their logarithm and put the results on this column. Just to apply, check and do OK. We will do the same with this. So again, set column value. This time will be the logarithmic function of the column B. Again, apply, check. Everything is fine and okay. So now we have our data. This is log of our initial velocity and this is the logarithm of our iodine concentration. In order to have the graph with Origin, we have just to click these two columns and go here on this straight line, and you will see that directly this beautiful program will give you directly the graph. So it's very simple, very easy. But how we can calculate the slope, which is what we want to obtain? Actually, we can do it using what is called linear fit. So let's go to analysis. Let's go to linear fit, open dialog. We see that we have here as input data the data of column D and C. So just check that everything is correct, then press OK, and you will see now that we have two new tabs, fit linear and fit linear curve. We will use just the first one. Now, as you can see, we have the parameter we were looking for, so intercept and slope, which are here. And now we have also, if you go down again and double click here, we will have also the graph of the linear fit. You can adjust it as you wish. We will, for example, erase this and put this table here. So let's see if I can copy table and paste. So we have our table here, which is what we wanted. You can also here write what is it. So it's log of concentration of iodine. And here is the logarithm of initial velocity. Okay, so we have our beautiful graph here. And our answer, which is actually the answer for our first set of data, will be 2. So we can already write V equals K times iodine concentration, and we can put the order of the reaction respect to iodine, which is 2. But now we have to consider also this second set of data in order to know what is the order of the reaction respect to the argon concentration. And this is what we can do with our second set of data, because in this second set of data is the atomic iodine, which is constant, whereas we are changing the concentration of argon. So as we have done before, we will put this data into Origin. We will actually do a new data sheet here. I will now again put the data and speed up the video. Okay, again, I will add 2 new columns. We have now this new column. We will set this as the logarithmic values of this value here in the column A. So let's do that. Set column value log, very simple, column A, close all the parentheses, apply, OK, and it's done. The same we'll do for this one. Set column value log column B, close everything, apply, OK, and we have also our data. Let's check if this is a straight line. Let's check it, and yeah, it is. And now we don't care about that, and now we will do our linear fit in order to have directly calculated the slope. Okay, we have the correct data inside. Let's do okay. Let's see fit linear, and actually you can see our slope, our intercept, and our graph here as we've done before. So let's adjust our graph as we like, and let's insert this important table with our parameters here on our graph. So as you can see, the slope is 1 for the argon. Actually, this is argon concentration. Sorry for that. So the slope is 1. So it means that the order for the argon is 1. Now we can put these two graphs together and we can write the answer for our problems, which is the order of the reaction for iodine 8 ohms is 2, and the order of the reaction for the argon is 1. And this is our kinetic law, so the answer to our exercise. So the exercise we have just seen is not the typical exercise to be performed during chemistry examinations, because most likely you won't have a computer during your examination to draw a straight line and then calculate the slope. Therefore, most likely during your exam session you will be faced with an exercise very similar to the previous one, but to be carried out in a different way. Let's see that. Let's take this generic equation A plus B plus C, which give us the products. For this generic equation, the following data have been found. What we have to do is 1. Formulate the kinetic law of the reaction. 2. Establish the order of the reaction. 3. Determine the kinetic constant. And 4. Predict the rate of the reaction in the experiment 5. So let's start from the first question. To determine the kinetic law, it is first necessary to calculate the order of the reaction with respect to the species A, B, and C. So let's start with reagent A. As can be seen from the table, the experiment 1 and 2 can be used for the calculation of the order of reaction for A, because the initial concentration of B and C in these two experiments are steady, whereas the concentration of A changes. Therefore, from these two experiments, I can get the information on the influence of A on kinetics by writing this equation. Since the concentration of B and C in experiment 1 and 2 are equal, we can erase them. And the same we can do with the constant K. Hence, the equation becomes this one. So now we can put numbers in our equation, so we will get that 2 equals 2 to the A power. Now it's easy to understand that A, in this case, is simply 1. So we have now obtained the first order. Let's move to the order for species B. For this purpose, we can use experiment 1 and experiment 3, where B changes, whereas the concentration of A and C is constant. So now the equation for concentration of B will be this one, because we have again erased the concentration of A and the concentration of B, as well as the constant value, as we have done before. The exact same procedure. So let's put number in this equation and we will have these things here. Now, to obtain the value of B, now it's somehow more complicated because we have an exponential equation. So to resolve this exponential equation, we can use logarithms. So our equation will become this one. And now it's easy to understand that B is actually given by the ratio of these two logarithms, which actually is equals to 2. So now we have also the second order with respect to the species B. The last one is the order for the species C. In this case, to have this last number, we have to consider experiments 4 and 3. So we can write this equation. Let's put number inside and let's use logarithms to have the value of C. So in this case, C is again 2. So now we have finished the calculation of the orders. So we can actually write the kinetic law. So the kinetic law will be V equals K, concentration of A, the order of A is 1, so we can skip to write it, then times the concentration B to the second power times the concentration of c to the second power again. Now let's answer the question 2, which was what is the overall order of the reaction? Now it's actually simple because the overall order of the reaction is done by the sum of the orders for single reactants. So it will be 1 plus 2 plus 2, which is actually 5. So the overall order of reaction is 5. So we have answered also to the second question. Now let's move to the calculation of the kinetic constant, which is our third question. To do that, it's actually very simple. Just take some data from our table, put this data in our kinetic law, and calculate the kinetic constant. For example, let's take the data for experiment 1. So let's write the kinetic law with these numbers. And now, as you can see, we can calculate easily the value of k because it's the only unknown quantity we have there. So k, it will be given by this equation with this result. Finally, to determine the rate of the reaction in the experiment 5, which is our last question, it will be sufficient to insert all the data of experiment 5 in our kinetic law with also our kinetic constant we have just calculated. So put all the data there and you will get the number of our initial velocity for the experiment 5. So this was the method of initial velocity, which is called like that because actually during the measurement we will consider only the concentration at the beginning of our reaction and the velocity at the beginning of our reaction. It is done because it's more easy to have these numbers. So if you want to know how to calculate in the lab this initial velocity because you are curious, you want to know where these numbers we have seen come from, then you can actually go on my website, which is operacam.com, in which you can find in-depth analysis also about that at the end of my article about kinetics. So I will put the link into the description box. Thank you for watching.